All right, listeners, get ready for a deep dive. Today, we're going to explore the fascinating world of large language models, LLMs. You know, those powerful AIs that seem to be everywhere these days. But here's the twist. What if, instead of just making them bigger, we could make them think deeper?
That's exactly what we're going to unpack. Oh, wait, someone wants to join. Hey, go for it.
Hey, thanks for having me. Can we uh can we talk about the overview of the intuition of this study and go through the key points for the beginning?
Hey there, thanks for joining in. I'm glad you're excited about the study.
Yeah, we're thrilled to have you. It sounds like you're ready to get to the heart of the matter.
Absolutely. We can definitely walk through the key points of how mind evolution works. It's a fascinating concept.
Okay, so let's unpack this. This whole mind evolution idea, it's like inspired by genetic algorithms.
That's right. It's like natural selection, but for AI solutions.
So survival of the fittest, but for algorithms, I love it.
Exactly. The best solutions evolve over time, improving with each generation.
Okay, I'm picturing AI solutions battling in a digital arena. Only the strongest survive.
Haha, sort of. The evaluator helps determine which solutions are strongest.
Okay, so it's not pass-fail. The evaluator provides detailed feedback.
Exactly. It guides the AI towards better solutions.
Gotcha. So walk me through the step. How does this all play out?
We start with what we call population initialization. We create a bunch of potential solutions.
So like brainstorming a bunch of ideas.
Yeah, and then we move on to evaluation. The evaluator scrutinizes each solution.
Like a super detailed quality control check.
Exactly. Next is selection. We pick the best solutions based on the feedback.
So weeding out the duds, focusing on the good stuff.
Yeah, and then recombination. We combine the best solutions to create even better ones.
So breeding the best solutions together.
Right. And this has two parts. Crossover, where we mix solutions, and mutation, where we add randomness.
Mutation. Okay, so the AI gets superpowers.
Well, not exactly superpowers. It's just to make sure we're ignoring all the possibilities.
Okay, I like that. But this cycle repeats itself.
Exactly. It goes through a number of generations. Solutions get stronger with each generation.
This is making sense. Now, what about the island model?
The island model helps keep things fresh. Imagine isolated islands, each evolving its own solutions.
Each island is running its own experiment, testing different approaches.
Precisely. They share their best ideas with each other.
So, cross-pollination of ideas. What if an island isn't doing well?
Then we do an island reset. We repopulate it with strong solutions from other islands.
Makes sense. So that's the theory, but how does it work in practice?
It was tested with several benchmarks, like the travel planner, trip planning, and meeting planning tasks.
Oh, tell me about those. How do they put this to the test?
The travel planner creates personalized travel itineraries, taking into account budgets, travel dates, all of that.
Oh man, that's me every time I try to plan a trip.
It's complex. Mind evolution achieved over 95% success.
95%. It's like having a personal AI travel agent.
And with a two-stage approach, they achieved 100% success.
Wait, a perfect score. I'm impressed. But is it a one-trick pony?
Not at all. That leads us to the natural plan benchmark, which includes trip planning and meeting planning.
Okay, so break those down for me. What does trip planning involve?
It's about creating efficient travel routes, like optimizing trips with multiple cities.
So like figuring out the best way to hit all the major landmarks in Europe in 2 weeks.
Yeah. Mind evolution also achieved an impressive success rate with that task.
So this AI can plan vacations and optimize travel routes like a pro. What about meeting planning?
This is the scheduling meetings between people, taking into account availability, travel times, all that.
Okay, my brain hurts just thinking about that. How did Mind Evolution do?
It did remarkably well, and with that two-stage approach, it did even better.
So we're talking about an AI that can plan your dream vacation and optimize travel routes and schedule meetings.
Yes. There's also the Steg Poet benchmark, which is about hiding messages within creative writing.
Steg Poet, what's that all about?
It's about embedding code within the words of a poem.
Okay, now that is cool. Can it tap into creativity?
It pushes the boundaries of what LMs can do, and it achieved an 87% success rate.
87%. Okay, color me officially mind blown. But what about limitations?
Ah, yes, we must discuss the limitations to this technology.
Yeah, we've talked about all the amazing things, but there must be challenges.
A key limitation is its dependence on a programmatic evaluator, a set of rules a computer can understand.
So it's limited to problems where the correctness can be clearly measured?
Exactly. Things like creative writing or music are hard to evaluate programmatically.
Because there's no single right answer?
Precisely. But the researchers suggest LLM-based evaluators could be a game changer.
Wait. All right, listeners, get ready for a deep dive.
On the Steg Poet task.
87%. Okay, color me officially mind blown. But
Mhm.
before we get too carried away with all this awesomeness, I think it's important to talk about the elephant in the room. What about the limitations? Are there any downsides to this approach?
Yes, that is a crucial question. Every groundbreaking technology comes with its own set of limitations, and mind evolution is no exception. To dive into those, well,